Hello everybody. This video will be the end of the section. We go into the ends of everything, right? And the section of the dynamic regression model will be the thing we're gonna just try to do to represent about how the model can be the combination between the time series regression. That's what we have already learned in the chapter 5 and the ARIMA model. That's based on the ARIMA model of the error term. That's we already learned something from the chapter 7 and 8. Okay, so when we combine both of them, we can develop a new model called the dynamic regression, in which we have the dependent variable explained by the independent variable or the predictor, and also for the error term of the model, it's no longer a white noise, but it's a model. It's going to be a result of the ARIMA model based on the historical data of this cell. Okay. And in this section, I introduce you guys about how to run for regression with the ARIMA error term. We will gonna learn about how we can conduct them on RStudio from now. Okay. Like always, I have already loaded for the package required, including for the FPP2 and also for the tidyverse. And now we go and use for the demo on the US chain datasets. And if you remember about that, this will be a growth rate of the personal consumption and personal income that is quarterly data, okay, including for the consumption expenditure and also for the income from the 1960 into the 2016. And if you want to see about that, I can show you about some of the first few observations. Okay, we have the data of the consumption, income, production, saving, and unemployment. This has been the data we used before in the previous chapter of the chapter 5 about regression, time series regression. But however, today we try to just represent it into a higher level, right? So first of all, like always, let's take a look into the data visualization. Here, just be careful because I will just present two variables, including the dependent variable consumption and the independent variable income. Okay, so we going to just use for that, and we use the function chain, US chain, and I want to see about the first and the second variable. If you remember about them, so if we plot it on, that should be just the consumption and the income from the first quarter of 1970 into the first quarter of the 2016. Okay, and with this data already selected, I'm going to just plot it out by using the auto plot like always. But over here, remember, beside of all the kind of X level, like X we can use this like year, Y level, I can just keep it clean, and also I can add it for the GC title. Okay, I say this will be quarterly chain in the US consumption and personal income. Okay, but remember, if I just run it like this, two variables will overlap on each other, and some of them, like for example, the chain in the income can be maybe stronger, much stronger than the consumption. So we fit them in as the same plot is not necessary and not suitable. So remember, I have to just use the faces, okay, equal to true. Sorry. So I can separate them out. And now the consumption and the income has been already created. Even when it look like the income, for example, they quite stable throughout, just fluctuate horizontally throughout like the mean of 0. It's not true with the consumption, right? So it looks like the data itself is not so stationary. And to do that, normally when we deal with the data, and also we see the problem about seasonality, right? So to do that before, when we run it for the model, we can normally do it in the last chapter by the ARIMA model, if you remember. Okay, so I will use the auto ARIMA function to just your chain. I select for the consumption. Okay, so this will be the predictor, the data that I wanted to predict. This will be consumption variable. Why I used for approximation equal to false. Remember, this will help me to run more result, and we will try to do further and further to just get the better estimation of the ARIMA function. And also for the step 1, I will clarify them into form 2. Alright, unchain. Okay. Yep. Is running, and after that, we will see the result like this. But it's not so good. I will say it will be fit 9.1. That's be the first model I fit to, and I say them into the object. Okay, summarize them to just say the result. Okay, and you see this one will be a seasonal ARIMA model with the 3 autoregressive. That means we're here first autoregressive, second, and the third autoregressive, right? And also we don't have the integration, we don't have the moving average for the non-seasonal part. And the same with the seasonal part, we don't have the 2 later component, but we have the first, like the 2 seasonal autoregressive model. So that's why we have the seasonal aggressive last one and seasonal aggressive last 2, and the mean values of the even for the constant and also for the YTCs look over here. And let's take a look. We have the BRIC Akai key information criteria, corrected Akai key information criteria, and the BIC. This could be the criteria we use to compare between the performance of the different model. Alright, so this is our traditional convention ARIMA model we learned already in the previous chapter. Now, let's just do it with the dynamic regression, okay, model. With here the predictor income with the ARIMA in error term. Okay, the error term will be estimated by the ARIMA model. So one more time, I use for auto ARIMA, and my targets will be UHN consumption. Okay, another one, I want for the X variable regression equal to, here I want to use for the US chain and of course income. Okay, so understand that the Y variable, the target variable will be the consumption, while the X regression, that's one will be income. And if I run it like this way, they will be automatically understand this will be a dynamic regression model. Okay, so if you want to see the detail about the result, I will call this one will be fit model, and I'm going to summarize them, and we will see any kind of thing we want to see. Okay, so this is, they understand this will be the series of the consumption to be the target, and this is a regression with the ARIMA 102 error. Okay, so for the error, it's appeared like with the 1 auto regressive and also the 2 moving average. Okay, and this will be represented into this one. You want to understand about how they can present it one. Okay, this could be the result. Okay, this will be the result, and you take a look into how they can represent. This will be the previous auto ARIMA model, and this will be the dynamic regression, and we see like this can create with the x regression. That means the parameter go with the x values, and the intercept over here we can represent the thing. This is the first model, and then for the error term, they will be there. The represent with the ARIMA model without the integration. That's the reason why we don't have the slab here. Also for one auto regression, that means it's come back for last one, right? Last one will be like 06922. This will be the model. And also we have the two moving average. That means the historical data of the error term into log 2 and log 1, okay, and we represent it over here. We also have the sigma estimated over here to just tell it about that should be normal distribution for the white noise of the error term in their error term ARIMA. But anyway, this is not really so necessary. The thing what I want to show you will be like if you go and check it, we see the corrected IAC for the auto ARIMA model regular, they is a little bit smaller than the new model. Okay, so that means with the dynamic regression model, their performance is a little bit better. Okay, so that's how the people can run it for the model. Now I don't want to waste the time too much, and let's go and just recover the estimation. I want to see the estimation of both the regression error term. That will be represented by eta, right? That's the regression of the model. Okay, the regression model. So I take the residual of the fit model and type will be the regression component. Okay, and I call them going to be like regression error. Another one, I want to see the error of the ARIMA model of the error term. Theta, so this one will be like epsilon. The epsilon will be include, and the type will be innovation. That means the error term. Okay, and then combine them at the same time, and I want to plot them. Okay, with the faces equal to true. That means I separate them out into the regression model. They fluctuate but going around for 0, and the same thing happened with the ARIMA term. Okay, that could be one point. Another way, we can also go and check the residual of the model. Okay, and this could be the work like when we go in and check residual like always, and we use for the fit model. Well, those we already learned about. We see this will be the time series. We see this will be the auto regression. We see this will be distribution. And also for the Legend box text, the p-value is larger than 0.05. That means the time series of the error term of the residual, they are white noise. Okay. And in case like if you really want to just represent and display for the timeline, the time series of the residual, I provide you guys also for the extra coding over here. Okay, so with the fit model, I want to just represent about the time series of the regression residual. Okay, and they are look like this way. Okay, and another one for the error term, I can also display for the residual of that one. You can see it over here.